3.6. We're going to do some more graphing, but you remember how y equals mx plus b is way easier to graph a line? Let's do that with parabolas. So as I alluded to in my introduction, we're going to do kind of the y equals mx plus b version of parabolas. So what that means is we're going to have a formula, and it's going to be way easier to graph from because it's going to give us more information. So the name of that formula is just a quadratic function in vertex form. So when I say vertex form, that means that we're using this new format. So the equation should look a little familiar from whenever we're doing like the transformations and things like that. So we've got in our parentheses, notice we have a squared right there. We have a on the outside. We have x minus h. Remember that h is going to switch signs whenever we pull information out. And then we have plus k on the outside of the parentheses. So a times the quantity of x minus h squared plus k. So this is called vertex form. And from that, we can glean a lot more information. So our vertex is going to be hk. So remember, there is a negative sign there. So when you pull an actual number out of it, that sign is going to switch. Yes, I'm repeating myself over and over and over again about that. There's probably a reason why. It's the number one mistake when we start pulling the vertex out. We forget that sign switches. Anyway, so we've got our vertex, we've got our h and our k. That turns into our vertex. Our axis of symmetry, I always view it as it's just the x value of the vertex, but yeah, it's also h. And the width and direction of the parabola is determined by a. So if that a is going to be negative, it's going to be flipped down. And then whether it gets compressed or stretched, that a number is going to determine that. So why should we use this? Obviously, we can see the vertex very quickly. We don't have to do any math. We don't have to do any work. We just have to look at it. And it gives us a connection to those transformations that we did. So if you remember, the parent function of our quadratic formula is just f of x equals x squared. And we can use that to use our transformation properties to kind of figure out what the graph looks like. So let's do some real quick transformations. This is kind of review. So remember, our parent function here is just an x squared. So if we have plus 9 on the outside, we're going to go up 9 spaces. If we have a minus 2 on the outside, we're going to go down 2 spaces. But if we put that number inside of the equation, like this guy right here, we're just going to go left. Remember, it's the opposite of what this sign is. So there's that minus h. That's what I was talking about. Here, we also have a negative sign, so that's a negative 1a. So that means that this is going to be reflected across the x-axis, and then it's going to move left 5 units. So here we've got both. So moving left to right, this guy's going to move us right 4 units. Again, it's opposite because of that negative sign. And then this one's going to go down 1 unit. So again, on the outside, it doesn't switch. On the inside, it does. So then here we've got a compression by 1/3. That's what that a value does right here. It squishes it a little bit. And then we've got this 2 value, which means that it moved up 2 spaces. And so the 2 on the outside will stretch the parabola. The negative sign will reflect it. And then the 4 right here is going to move it to the left 4 units. So let's try a word problem. Oh no! So here we go. Mason graphed the parent function of a quadratic equation. Then he reflected the parabola over the x-axis and translated it 7 units up and 3 units to the right. What is the equation of the new parabola? So parabola, our parent function, is x squared. That's a terrible looking square, but whatever. So let's see here. Parent function. Then he reflected it over the x-axis. So that means that we're going to have a negative sign out here. Translated it 7 units up So I'm just going to close that. So 7 units up would look like that, and 3 units to the right. So here's where it always gets confusing. I think up to the right is the positive direction, but it's inside, so the sign switches. So it's going to be a -3. And just to be correct, so that's how you take those words and translate it into an equation. Okay, so graphing in this section is the exact same except less work, because we don't have to do any math to find the vertex. So if we are looking at number 8, I can look at this very quickly and see that my vertex is 2, 3. Notice this thing changed signs, this thing changed the same, or stayed the same. So our vertex is at 2, 3, and then this is our axis of symmetry, and that's just going to be at x equals 2. I actually probably won't label that all that much. I take it back, they asked for it. But that's why I put it in there, because they asked for it. So read questions carefully. Anyway, so what we did last time is we threw some points at it. That's what we're going to do again this time. So we're going to, we'll just go 2 points in either direction. And again, use the calculator for this if you don't want to do the math. Enter it into the y equals function, and then from there, do second graph, which will take you to your table, and then enter in your values, and your calculator will tell you that those values are these things right here. And then from there, let's just graph. So my vertex is at 2, 3. 1, 2, 1, 2, 3. And then 3, 4. 1, 2, 3, 4. And then 4, 7. 1, 2, 3, 4, 5, 6, 7. And there you go. So we can also very quickly look at 9 while we're here. Our vertex is going to be, without doing any math, there's nothing attached to that guy. So our vertex is going to be 0, -4, just by using that parent function that we learned earlier. So that's our vertex. And then our line of symmetry is just going to be x equals 0. So from there, we throw some points in. -1, -2, 1, 2, -3, 0, -3, 0, and we can plot it. 1, 2, 3, 4. Let's see here. Oh, that's totally wrong. X is 0, 1, 2, 3, 4. Y is -4. Sorry about that. And then 1 is -3. 2 is 0. See? Even easier than than the last section, right? So that's all this is pull the vertex out, throw some points at it, and graph the equation. Since the process is kind of the same, I'm gonna more or less skip some of the examples, but hey, there's a piecewise function here. Let's do that, because everybody loves piecewise functions. So we're looking at number 12. Step 1 with any piecewise function for me is I'm going to look at my boundary line, and in this case, it looks like it's gonna be at x equals -2. So I'm gonna draw a dotted line at x equals -2. So then on the left side of it, it's going to be this guy, and on the right side of it, it's going to be that guy. So we're going to start with the left. We're going to make that guy red. And that looks like just a normal line to me. So there's no x squared, there's no nothing, it's just a normal line. So a -6 is my b, so that's going to be my y-intercept. 1, 2, 3, 4, 5, 6. And then we're going to go, I'm going to put the negative sign with the 2. So we're going to go up 1 to the left, or whatever. Up 1 to the left, 2. So 1, 1, 2. 1, 1, 2. 1, 1, 2. And we're going to stop at that boundary line. And when I look at this sign right here, that's a less than sign. So that means that it's going to be an open circle. So then we will do blue for the right side of the boundary sign. That's where we get our parabola. So our vertex here is going to be at +1, -5. If I were to do my XY chart, I've got 1, -5. I guess we'll go to 2 and 3, and then 0 and -1. And let's see here. I'm going to actually have to use my calculator because I don't have those pre-done. I'm actually just kidding. I don't need my calculator because I know my translation. So believe it or not, I'm just going to draw a parabola. This would be the parent function of a parabola. And because I have this wonderful technology, we're just going to move that graph. So I already know the vertex, so I'm just going to move that graph to the vertex. So it's at x = 1, -5. So 1, then we're going to go down 5. 1, 2, 3, 4, 5. And we can kind of spiffy it up a little bit. We'll just extend that out. That looks terrible, whatever. And I'm looking at this thing right there. This is going to be an open circle. And I'm good with that. So let's keep going. Quick inequality here. So hopefully you're getting the habit of you just graph stuff, and then when we throw an inequality in it, you're going to have to shade on one side or the other. So here I'm looking at number 14. My vertex is at +3, 0. So I can pretend like there's a +0 on the outside. That's where that 0 comes from. And I'm noticing this is going to make it face down. So that's just a good thing to know later on. If you didn't recognize that, as long as you do the math down here correctly, you're fine. Or if you enter it into your calculator correctly, you're fine. It'll all come out in the wash. So our vertex is at 1, 2, 3. Then we're going to go down. That's my 2 and 4. My 5 is going to be -4. 1, 2, 3, 4. 1, 2, 3, 4. Am I going to do a solid or dotted line? Okay, so that means I'm going to do a dotted line. I still hate dotted lines. I just can't see them as well. Whatever. My dotted line looks like garbage. Okay, so we gotta graph some stuff. No, shade some stuff. So this says y is less than all of that equation. So I'm gonna shade underneath it. And the other, what is it? The other method is we can pick 0, 0. And if I plug that into it, we'll get 0 - 3, which is -3, squared, which is +9. Then we have this negative sign out here, so we're going to have -9 plus 0. So then we're going to have 0 is less than -9. That is a not true statement, which means we would shade away from the origin or whatever your point that you chose was. So that's about it for this section. Again, the big thing is being able to pick out a vertex from the equation here. That's all it is.